Hello all, welcome to Code Hub. Consistency is the key to success. And come today, let's solve the LeetCode daily challenge. The question is triangle, and the question states that given a triangle array, return the minimum path sum from top to bottom. For each step, you may move to an adjacent number of row below. More formally, if you are on index I on the current row, you may move to either the index I or index I plus 1 on the next row. Okay. Mm, let's take the example and work out and see. You can get a clear understanding. Mm, yeah, this is the triangle. Consider this is the triangle. Here, if I am at this current 0th row, I can move to the next row and I can take the value which is at 0th index itself or 0 plus 1 first index. Consider if I am at this index. This is nothing but 1 1. The position of this 4 is 1 1, right? I want to move to the next row and I can take the current element 5 which is at first position in the second row, which is second row. I am saying in based on 0 based indexing, or in 1 based indexing it is third row, it is first index, right? Or I can take this 7, this is I plus 1. Let me say in one based indexing itself so that it will be more clear. If I am at this first row, then I can go to the next row and I can take this first index or the next index. I consider I am at this 3, then I can go to the next row and I can take the same this first index or this 5. Or consider I am at this 4, the element 4, which is at position 1. Then I can go to next row and I can take the same position that but in next row, or else I can take the 7, that is that they are indicating as index I or index I plus 1 on the next row. Hope you get a clear understanding of the problem. I should minimize the path sum. I will get a path sum. I should minimize that. So obviously we can't go with a brute force approach because there will be many possible ways. Some of the possible ways I will depict here. Some of the possible ways are I will take 2 and then I will go to my next row and I will take 3, and I will go to my next row I will take 6, and I will go to my next row I will take 4. And what will be the path sum here? It is 15. Consider I am taking 2 in the first row and I will be going to my next row and I will be taking 4, and then in my next row I will be taking 5. After taking 4 I will be taking 5, and consider I am taking after 5 I will be taking 1. So the path sum here is 4 plus 5 9 10 11 12, it is 12. Consider we are taking another path 2 plus 3 plus 5, that is I from 3 I am going to the next row and I am taking this 5, and then after 5 I will be going to the next row and I will be taking 1. Then what will be the sum here? 2 plus 3 5, 5 plus 5 10, it is 11. And this is so there are many possible ways like this from first row to reach last row. There will be many possible paths, and in that path we have to minimize the sum. That's the problem, and the most optimal solution here is 2 plus 3 plus 5 plus 1, which is 11. So we should return 11. So hope you understand this. Since there are many possible ways, we can do a recursive solution here. So recursive approach. Here we will be considering all possible paths. This will be the obvious brute force approach. So how we are going to do this? If I am in current row, I will be going to my next row. If I am picking this element, I will be going to my next row and I will pick the same element or the next element. So there are two options. Either I will take the current element and then I will go to my next row and then I will pick the pick the element which is on the same column or else the next column, right? This 3 is in the next row and in the same column, or I can pick the in the next row 4 which is in the next column, right? If I'm at 4, I will be taking the next row. I will be taking the element which is in the next row, which is in the same column, or the next column, right? 7 which is in the next row, next column. So obviously, if I consider this triangle, I will be taking the options as I will be going to next row. Consider row plus 1. I will be going to my next row and I will be taking the current column itself, or triangle next row, next column, the element which is in the next row, next column. So this will be the two options that I will be taking. So let us write a function which is going to be a recursive function that is going to return me the minimum path sum. I will call this function as solve. What are the parameters I'm going to pass here? I will pass the triangle vector and I need the length. I need the row count, right? Row count. In row is triangle size. Row size. I will name it as row size. And I will start from the 0th row and I will pass the row size as well. That will be needed because we will check a base condition. Hope you get it. Wait, I will show it. So this will be the function solve. This is going to return me the minimum path sum in triangle and int row and int row size. Even I will need a parameter which is column, right? You can see I'm accessing row as well as column, so I should pass column value as well. So I will start from 0th row, 0th column, which is 2, and I will check whether I reach the last row. If I reach the last row, I will be taking the minimum path sum. This was going to give me the minimum path sum. Okay, what will be the base case? If my row is equal to my row size, then obviously I have reached the last row. Then I can return 0. Right? Yeah. Okay, now what are my options here? Option 1 is if I'm taking the current element, which is triangle of row call. If I'm taking the current element, I can go to my next row and I will be taking either the next row, the same element, or the next row, the next column element, right? These are the two values, either row plus 1 call or row plus 1 call plus 1. So I will pass the triangle, then I should go to my next row with same column number, row size, or another option which is I can take the current row call and I can go and recursively solve the other sub problems with next row, next column, and row size. And finally, what we are going to return? Minimum of both the options, option 1 and option 2. Okay, we can just, these are the two options. so that it will take all possible ways. Let's run the code and see. Okay, triangle of row call. Okay, fine. It is actually vector of int. I have given only vector of int. This may give conflict. We can just run the code now. Yeah, it works fine. And this is a recursive solution, so there will be the time complexity of this solution will be 2 power n, since for each approach we are going going through two options, so it will grow exponentially. We can just give submit and see. uh, yeah, we got time limit exceeded. So since we are the constraints are big, the brute force solution, this recursive solution may not work. It will not work. It will give TLE obviously. So we can just do a since it has overlapping sub problems, we will be solving the repeating problems more, so that this gives a time limit exceeded. So we can just cache the result, and we can return it once we have computed earlier. So this approach is nothing but the dynamic programming. So we will just convert this recursive solution to a dynamic programming very easily, because we have written the recursive solution. It is not that difficult to convert it to a dynamic programming solution. I will show that how it is done. Here, what are the changing parameters in our recursive solution? You can see that the row and the call are the only two parameters which is changing. So we can just have a two-dimensional DP array. We are doing memoization in the recursive solution. We are doing memoization. If we do a tabulation without using a recursive function, it is known as the tabulation, but I will say the name as dp itself, dp, and its size is from row size, and it is a two-dimensional vector of row size, and I will initialize with -1 initially, and I will pass the dp itself, and it is a vector of int. It is that easy way to convert a recursive solution to a dynamic programming solution. We have to pass the dp array. We have just passed the dp array. Yeah, then we have to just cache it. We'll store the intermediate results, dp of row call, and we have stored the result. Now once we encounter it, that is when once we have computed a previous result, and if the result that is stored in dp of row call is not -1, then we will return that dp of row call itself, and we have done it. Now we can run and see. And this is a dynamic programming solution. It is that easy to convert the recursive solution to dynamic programming. Now we can submit and see whether it is running or not. It got accepted. Yeah, cool. And hope you liked the video. Here the time complexity of this solution is time complexity, I will write here. The time complexity of this solution is order of n into n, where n will be the number of rows. We are using we will be storing the results intermediately, and we will be returning back once we have seen it before. And what is the space complexity here? Order of n into n. And yeah, since it is a recursive solution, we will be using a extra auxiliary stack space, right? Auxiliary stack space. This will go till order of n. So this is the space complexity here. Now we will convert this recursive solution, and we will try to eliminate this auxiliary stack space using tabulation method. Using tabulation, we will just make this dp array to initialize it with 0, and we will observe what is the base case here. The base case is that whenever the row reaches the last row, we are just storing the last row elements in our DP array. We are just returning 0, right? If we are consider it is a row dot size -1, then we are just taking the last row elements as it is. So we will run a loop for int I equals to 0, I less than row size I plus plus. Here in DP of in last row n-1, we will come in alternative fashion. This in recursive solution we are going from top to down. Here we are going to go from bottom to up. It will be in alternative manner. So we are storing in DP of n-1 I as triangle of n-1 I. Hope you understand this. Now what we are doing here, we have done the base case. Now we can just run the for loop instead of the recursive approach. We have the last row here. So the row starts from n-2. N is nothing but row size -2. Last before row. Row is greater than or 0 and row minus. And we should have another for loop which is called int call that starts from I to 0. Since in each row we are having only one element less than that, right? So which is row to call greater than or equal to 0, call minus, and we will just copy the recursive solution, the other recursive solution that like itself, and we will paste here. Now we will take this recursive function. We don't want this now. So yeah, the int option 1 is triangle of row call. Instead of this recursive function, we will change it as DP array. DP of row plus 1 call. And similarly here also it is DP of row plus 1 call plus 1. Row plus 1 call plus 1, and instead of returning here we will store a DP of row call as minimum of both the operations, and finally we are just returning the DP of 0 0. Hope you understand this. We can just run and see. Here the time complexity will be, this is tabulation method, this is memoization. Here for tabulation it is time complexity. Here time complexity will be order of n into n, and space complexity will be just order of n into n. And we can just run the code now. We have done the both memoization and tabulation as of now. Row minus call minus, why it is taking this time? Here actually it is row size -1, and similarly the n is also row size -1. Meanwhile we will change this, and we will just once copy and we will refresh the screen. Maybe there will be an internet connection. Yeah, hope there is some internet lag from my side. 1 minute. Yeah, I am back. Now we can just run the code again. Hope the net will be connected soon. Yeah, it is perfectly accepted. We will use the example test cases as well. Yeah, it got accepted. We will submit it. This is a tabulation method. Yeah, this got accepted. Superb. Nice. And for tabulation, the time complexity and space complexity is order of n into n. Even we can optimize this tabulation, the time space complexity. We can optimize the space complexity to order of n. Optimized tabulation. Here, the time complexity will be order of n into n, and space complexity will be order of n. Let's see how we are going to optimize this. Here we are in need of only the next row. Instead of storing a two-dimensional vector, we can just have a single dimensional vector for each row, and we are, you can see that we are accessing only the next rows that current value, next rows next current value. Other than that, we are not needed of that at all. Two-dimensional vector, so we will just have a 1D vector of row size, and we will initialize it to 0, and this dp of this is nothing but next, right? Here triangle of row size -1. We will have two vectors, two temporary single dimensional vectors, next and cur, where cur also row size 0, and this is next, and this is next of call, and this is cur, right? Cur of call, and I will store, after which, after coming out, now my current becomes my previous, sorry, now my next becomes my cur, right? Now my cur is my next, cur, so now my next cur becomes my next, right? And finally I will return my next of 0. Let's run the code and see. It got accepted. Let's submit it. Here we are just running two for loops. So here the time complexity will be order of n into n, and the space complexity will be order of n. And this is the most space optimized solution here. We have done a recursive solution, then we have optimized it to we have done a dynamic programming memoization, and then we have optimized it to tabulation, and we have eliminated the auxiliary stack space in that, and after which we are also space optimized it, and we have done with space optimized as order of n. And even they have given the follow-up that could you do this in using only order of n extra space, where we have achieved it also. That's it, and thank you for watching, and thanks everyone. Bye.